Hello, hello. Myself, Professor H.K. Bhangade, Department of Electrical Engineering, SND College of Engineering and Research Center, Evla. I welcome you in video lecture series of Basic Electrical Engineering, which is a first year engineering course. So today we'll discuss on a single phase transformer. So in part A or part 1, we'll discuss today what is a transformer, what are the different types of transformer, so that we discuss one by one. So we are using alternating current in our daily use. So the alternating voltages can be either raised or lowered as per the requirements in the different stages of electrical network, just like generation, transmission, distribution, and utilization. So this is possible with a static device, and that static device is called as the transformer. So the transformer is a static piece of apparatus by means of which an electrical power is transformed from one alternating current circuit to another with desired change in voltage level without any change in the frequency. So the transformer is used to either increase or decrease the voltage level as per the requirements. The use of transformers in AC transmission system is there. So the transformer is just a static device which is used to transfer the electrical energy from one circuit to another. Now input to transformer and output from the transformer is always an alternating quantity. It is designed only for alternating quantities. So electrical energy is generated and transmitted at an extremely high voltages. The voltage is to be then extremely high voltage is to be then reduced to a lower value for its domestic and industrial use. So this is done by using transformer. So whatever the generated voltage at the generating station, it is very high voltage level is very high, and this voltage we have to transmit and distribute at the user level. So that we need that voltage to be converted or reduced its level to lower value. So for its domestic and industrial use, and this is possible only by using the transformer. So the power transmission system using transformer is shown in this figure. Here a generation station which generates the power or electricity, and when the transformer, this generating station generates it about 33 kV, and this 33 kV we have to transmit. So it first for transformer converted into by using a transformer into 13.5 kilovolt. So that level is lower from 33 to 13.5 kilovolt. Then at distribution station, that is substation, that 13.5 kV comes, and then again it is lowered there from 13.5 kV to 6.6 kV using the transformer, and then it goes to the distribution center. Then for consumer use, when we distribute it, so again at consumer level, it is converted into from 6.6 kV to 415 volts. Okay, so when the transformer changes the voltage level, it changes the current level also. So at a simultaneously voltage and current level are changes. So now let us look towards the basic principle of the transformer. The working principle of transformer, will see the transformer works on the principle of mutual inductance, which states that when two coils are inductively coupled, and if current in one coil is changed uniformly, then an EMF gets induced in the second coil. Here two coils are there that are wound on a transformer coil. Okay, now here I have applied, this is one coil, this is second coil. This is first coil is called as the primary coil, which is wound in this side. The second coil, it is called as the secondary coil, which is wound in the opposite side. Okay, both are isolated from each other. Both are isolated from each other. Now, when I will allow, as per the principle of the mutual inductance, what happens when I allow the flow of the current through this primary winding? That time, what happens? And magnetic flux will generate, and that flux will traverse to this magnetic core, that is transformer core, and in between there is a secondary coil, and whatever that flux that will link in this secondary coil, and due to that linkage of this flux in the secondary coil, that flux is induced in the secondary coil, the EMF is also induced in the secondary coil. So this is the basic principle used here, that is the mutual inductance. The primary winding is connected to a single phase AC supply here, and AC current starts flowing through it. Now the AC primary current produces an alternating flux, that is phi in the core. So this much flux phi is produced due to this primary winding, because AC supply is given to this primary winding. Now here no supply is given to secondary winding. Input is always given. Input is always given to the primary winding of the transformer. And due to the flow of the current through this primary winding, a magnetic flux will induce, and that will flow through this transformer core. The most of this changing flux gets linked with the secondary winding through the core. Now this flux is changing because the magnitude of the current always changes in the coil. It is alternating current. So this changing flux is also changes, and this changing flux link with the secondary winding through the core. Now the varying flux will induce the voltage into the secondary winding according to Faraday's law of the electromagnetic induction. Now according to Faraday's law of electromagnetic induction, what happens? This flux which is flowing in a transformer core, this flux already changes, because whatever the alternating voltage I have applied here, it varies. It varies, and due to this variation, the magnetic flux also varies, and this variable flux links with the secondary winding, secondary coil, and according to Faraday's law of electromagnetic induction, EMF will induce in the secondary coil. So voltage level change, but frequency, that is the time period, remains the same. Now, no doubt, whenever this transformation of the energy takes place from one circuit to another circuit, that time the voltage level changes. But whatever the frequency of the input signal, the same will remain at the output. There will no change in the frequency. So there is no electrical contact between the two windings, and electrical energy gets transferred from the primary to secondary. Both the windings are electrically isolated. There is no physical contact in between primary and secondary. Okay, there is no physical contact between primary winding and secondary winding. Only the flux linkage with each other is there, and due to that changing flux linkage with the secondary, EMF is induced in the secondary winding. A simple transformer consists of two electrical conductors called the primary winding and the secondary winding. The energy is coupled between the winding by the time varying magnetic flux that passes through links both primary and secondary windings. Now one question is there: can the transformer operates on DC? So what will be your answer? Obviously no. Transformer never operates on DC. Transformer only works for AC. The transformer action does not take place with the direct current of constant magnitude. Because of the DC primary current, the flux produced in the core is not alternating, but it is constant value. There will be no change in the flux. And as there is no change in the flux linkage with the secondary winding, the induced EMF in the secondary is zero. That's why transformer will not work on a DC. So if DC is applied to the primary, then what happens? Obviously, when you apply the DC to the primary, then there is a possibility of transformer core saturation. If the core saturates, the primary will draw excessively large current, and therefore application of DC should be avoided. So remember this: the transformer works only on AC and not on DC. Now let us look on the types of the transformers. The transformers are of different types depending on the arrangement of the core and the winding as follows. So the single phase transformers are classified into these three categories: core type transformer, shell type transformer, berry type transformer. The magnetic core is a stack of thin silicon steel. Sorry. The magnetic core is a stack of thin silicon steel laminations about 0.35 millimeter thick for 50 Hertz transformer. In order to reduce the eddy current losses, these laminations are insulated from one another by thin layers of varnish. So that core stacks are being varnished, insulated by using a varnish. So these are the three basic types of transformer. And in next lecture or next video clip, we will see in detail the construction and working of the core type, shell type, and berry type transformer. Till then, thank you very much.